Hello, dear students. As you know, in a previous lesson, we stopped here. This is the equation of free fall acceleration, okay, of Earth. So how can you prove this equation? G, gravity is equal to universe constant, mass of planet, and R square. Okay, so what does the free fall acceleration depends on? It depends on the mass of the planet and the radius of the planet. Okay, so to proving this equation, assume that, for example, this is Earth. Okay, for someone who's studying, for example, this is mass of this person. Okay, and the radius, distance from the center of Earth, this is R, okay, and this is mass of Earth, for example. As you know, Fg, the equation of the gravitational force, is equal to what? G, universe constant, mass of planet times mass of the person divided by R squared. As you know, to find the gravitational force, we can use this equation, this relation, mass times gravity, mass of person, which is equal to G, mass of planet, mass of Earth, our planet is here, is Earth, times mass of person divided by R squared. Mass cancel, what is remain? Gravity, free fall acceleration, which is equal to G, universal constant, times mass of the Earth divided by R squared. Okay, so what is the relation between R and G? Is inversely proportional. When R decreases, gravity increases, but when R increases, gravity decreases. Okay, so according to this equation, free fall acceleration, which is equal to G times mass of Earth divided by the radius of Earth squared, the amount of the gravity depends on what? It depends on the planet's mass. The planet here is Earth, and the planet's radius. So this equation can be used to all the planets. Okay. Question 24 from chapter review. Astronauts floating around inside the space shuttle are not actually in a zero gravity environment. So what is the real reason? The real reason the astronauts seem weightless. Okay. The answer is the astronauts and the space shuttle both have the same acceleration. Okay, so that as a free fall acceleration. As a result, the astronauts see everything at rest and believe that there is no force on them, but this is wrong. Actually, they have gravity, but the space shuttle and the astronauts, they have the same acceleration, free fall acceleration, and because of this huge distance between the astronauts and the Earth, the gravity is very weak. Okay, free fall acceleration changes as the distance of the body from the Earth changes, and it is inversely proportional. Free fall acceleration does not depend on the mass of the object, it depends on the mass of the planet. Question 21. Explain why Earth is not spherical in a shape and why it is bulges at the equator. Actually, the shape of the Earth is like that. Okay, it is not a complete sphere. Okay, so this is the axis of rotation of the Earth. The answer is why Earth is not spherical in a shape. Why it is bulges at the equator? It is bulges at the equator. This is equator. This is pole. Because the force holding Earth together is not large enough to resist the inertia of the points on the equator. So this is the first answer. The second answer, due to the great temperature of the center of the Earth as it is created, all materials are in liquid case, and as it is start rotating, the particles moves away. Okay, when the Earth rotating, what happens to the particle, the liquid particle inside the Earth? They moving away from the center because of what? Because of the inertia. And the force between the Earth's particles are not sufficient to resist this inertia at the equator. That is why the Earth is bulges at the equator. In a short answer, you can answer this question and you can say because of the inertia and this force when the Earth rotating, Okay, all the particles inside the Earth, they have an inertia on centrifugal force. Because of this inertia, the particles try to moving away from the axis of rotation. So that is why the Earth is bulges at the equator. So we have this difference between object at poles or object at equator. Before explaining this difference, I would like to tell you something about the poles and the equator. Assume that this is Earth, for example, okay, and this is axis of rotation of Earth, okay. For someone who's standing here, for example, where is the gravitational force? When the Earth is rotating, this guy also is moving in a circular path around the axis of rotation. So this guy, this person has a centripetal force, has what? Centripetal force which is directed toward the center. And also has a gravitational force. Okay? Because the gravity pulls everything toward the center of the Earth. So in that case, the normal force is opposite direction of the centripetal force. How can you calculate the centripetal force at equator? This point is what? This is equator. What is this? This is equator. At the equator, Fc is equal to what? Is equal to Fg minus Fn. Okay? So if you rearrange this equation, Fn is equal to what? Fn is equal to Fg minus Fc. So the actual the effective weight is decreases at the equator. So that is why the weight is less at equator. Why? Because a part of the force of the centripetal force acting on this body, so that is why the weight seems to be less. So this is the distance from the axis of rotation r. Okay, when we try to approaching the pole, what happened to the r? R decreases until it reaches 0. At this point, r is equal to what? R equal to 0. According to this equation, Fc for rotating object is equal to what? Is equal to mr omega square. When r is 0, okay, what happens to the centripetal force? Also becomes 0. So it means that at pole, this is pole. At pole, Fc is equal to what? Fc is equal to 0. Okay, so the person has gravitational force downward and normal force upward, so effective weight is equal to Fn is equal to Fg. There is no centripetal force at the pole. Okay, what is the magnitude of the centripetal force at the pole? At the pole, centripetal force is equal to what? Is equal to 0. Okay, so object at pole, object at equator. So this is equator and this is pole. At the pole, Fc 0, weight has maximum value. But at the equator, Fc is equal to Fg minus Fn. Weight is maximum, weight is minimum at the pole, at the equator, okay? Free fall acceleration is maximum at the poles, but free fall acceleration is less than the pole, okay? The centripetal force is less on the axis of rotation. Centripetal force is equal to what? 0. At where? At pole. But at the equator, centripetal force is not 0. You can see it's large, okay? Mass is constant. Also mass is constant anywhere. At pole, Fg is equal to Fn. But at equator, Fc is equal to Fg minus Fn. If you rearrange the equation, Fn is equal to Fg minus Fc. At the poles, object has not circular motion, has only rotational motion at the poles. But at equator, the object has circular motion. Look, question 22. Because of the Earth's rotation, you will weigh slightly less at the equator. The weight is less at the equator than you would at the poles. Why? What is the reason? Because at the equator there is a part of what? Centripetal force. Do we have centripetal force at the equator? Yes. This centripetal force, it causes to decreasing the weight. Okay, be careful. This is very important. But at pole, there is no centripetal force. The object has no circular motion. So that makes you remain on a circular path. The effective weight is less than the actual weight at the equator. Okay, so effective weight is equal to actual weight minus Fc. Okay, so when we say actual weight, it means that Fg. This is Fg. Okay, effective weight, this is Fn. Sample problem 1I, find the distance between 3 kilogram billiard ball. This is M1. This is M2. And the magnitude of the gravitational force. This is gravitational force. Find what? Distance, R. Okay? Because Fg is equal to G M1 M2 over R square. Rearrange the equation. R square is equal to what? G M1 M2 over Fg. Take the square root to both sides. R is equal to G M1 M2 over Fg. G is constant, mass 1 is given, mass 2 also is given, Fg also is given. You can calculate by the calculator, and the R is equal to 0.3. Okay? Question 1, if the mass of each ball in a sample problem is 4.8 kilogram, both mass M1 is equal to M2 is equal to 0.8 kilogram. M1, M2 is given. The gravitational force also given. Find the radius or the distance between the two masses. The same sample problem, same procedure, you can find it. As the mass increases, what happened to the mass? If you compare with the previous question. In the previous question, M1, 3, M2, 0.4, because mass increases, so that is why the distance, look at the force. They have the same force. The force here is negative. This is negative. Sorry. The same force, yes. Okay. At the same force, at constant force, R is equal to G M1 M2 over Fg. At constant F force, what is the relation between R and mass? Is directly proportional. Okay. Look, the R increases from 0.3 to 0.692. Question 2, find the magnitude of the gravitational force or a 67.5 kilogram person, mass of person. Sorry. Okay. 67.5 kilogram would experience while standing on the surface of each of the following planets. We have two planets, Earth and Mars. This is mass of the planets, and this is R. For the first one, for Earth, Fg is equal to what? G times mass of Earth, mass of person, divided by R square. This is 6.67 times 10 power negative 11. Mass of Earth was given 5.98 times 10 power 24. Mass of the person also is given 67.5 divided by the distance or the radius of the center of Earth, 6.37 times 10 power 6 square. By calculator, Fg is equal to what? 664 Newton. The same procedure you can use, the same step you can use to finding the gravitational force on Mars, but instead of the mass of Earth, you have to write down the mass of Mars, and it is distance from the center. Okay? We finished the chapter section 3 in chapter 1. Okay, now we are going to solve the questions from section review, section 3. Okay, we have some important question here. A roller coaster moves through a vertical loop at a constant speed and suspended its passengers upside down. In what direction is the force that causes the coaster and its passengers to move in a circle, and what provides this force? Actually, the force that maintained the passenger in the roller coaster is directed toward the center. Okay, the force is directed toward the center. When the roller coaster reaches the maximum point, what happens? The passenger becomes upside down. Okay, the direction of the centripetal force is toward the center. Fg also toward. Fn also toward the center. Why? Because the roller coaster is upside down. Be careful. At this point, all the three forces are directed toward Fc, Fg, Fn. Okay, so at this point, Fc is equal to what? Is equal to Fg plus Fn. The forces that provided the centripetal force is two forces: gravitational force and the normal force. This is at the highest point. But at the lowest point, look. At the lowest point, look. The direction of the centripetal force toward the center always. So Fg downward always. Fn is upward. At the lowest point, Fc is equal to what? Is equal to Fn minus Fg. So this is very important. Be careful. Okay? How can we determine the centripetal force? At the top point, highest point, and at the lowest point. At highest point, Fc is equal to what? Fg plus Fn. Why? Because all the three forces directed toward the center. But at the lowest point, Fc is equal to Fn minus Fg. Okay? Question 2. Identify the force that maintained the circular motion of the following. A bicyclist. Be careful. This is not bicycle. This is bicyclist. There's someone who's riding the bike. Okay, when we say bicyclist, it means that there's someone who's riding. This is bicyclist. Okay, and this is bicycle. The force that maintains the circular motion of the bicyclist moving around the flat circular track. We have three factors for the bicyclist. For the bicyclist, we have three factors. The first factor, number 1, the force of the bicycle seat on the bicyclist. Number 2, the friction between the bicyclist and the seat. Number 3, force of the bicyclist's legs grasping the pedal. Okay, this is the force of the legs grasping the pedal and handlebars. Okay, so how many factors that maintain the bicyclist in a circular track? 3 factors. The frictional force between the bicycle seat and the bicyclist, the frictional force between the bicyclist and the seat. Okay, the third one, the force of the bicyclist's legs grasping the pedal. B, a bicycle. What is the difference between A and B? In A we have bicyclist, but in B we have bicycle. Moving around the flat, just one reason that causes maintain the bicycle in the circular track. So this reason is the frictional force, Fs. Okay, Fs is equal to Fg for bicycle. For what? For bicycle. Okay. The normal force for the curved side of the truck. Okay, sorry, the question. A bobsled. What is the force that maintains the circular motion when a bobsled turning a corner? The normal force, such as a cylinder. Okay. Question 3. A 90 kilogram person. This is mass. 90 kilogram. Ride is a spinning amusement park ride that has an angular speed omega 1.15 rad per second. If the radius of the ride is 11.5 meter, what is the magnitude of the force that maintains the circular motion? As you know, we have three equations of the circular motion. Centripetal force, MAC, and VT squared over R, and R omega squared. Which equation can be used to find centripetal force? For this question, you have to look the given value. Do we have angular speed? Yes. In which of the following equations we have angular speed? Equation number 3. So that is why we have to use this one. And R omega squared. 90 times 11.5, 1.15 squared, which is equal to 1.37 times 10 power 3. This is question 3. We've finished it, chapter 1, fortunately, so hope you get benefited from my lessons, and I hope you guys understood this chapter. So if you have any question, feel free to leave in a comment, please, okay? I'm going to respond all the questions. And chapter 1, standardize the test prep. An object moves in a circle at a constant speed. Which of the following is not true? Constant speed, be careful. For constant speed, 80, okay? In a circle path. It is centripetal acceleration points toward the center of circle, yes, but the question says which one is not true. We have to looking for the not true, for the wrong. Is A wrong? No. It is tangential speed is constant? Yes, the tangential speed is constant, okay? We have to choose the wrong one, be careful. It is velocity is constant? No. The velocity is not constant in a circular motion. You have to say the speed is constant. Why? Because velocity is not constant in a circular motion because the direction of the velocity changes. Centripetal force acts on the object, yes. So the correct answer is what? C. Why? Because the question says which one is not true. Only C is not true. The others are true. A car traveling at 15 meters per second, this is VT, on a flat surface turns in a circle with a radius R. What is the centripetal acceleration? Centripetal acceleration, AC, is equal to VT squared over R, which is 15 squared divided by 25. What is the most direct cause of the car's centripetal acceleration? So the rectilinear motion of the car, no. The motion of the car with a constant velocity, no. If the force of the friction between the tires and the road, yes. Okay, the frictional force between the tires and the road provided the centripetal acceleration. Earth, the mass of Earth, 5.97 times 10 power 24 kilogram. Orbit the sun, this is mass of the sun, add mean a distance, this is the distance between them, this is M1, this is M2, and this is R. What is the gravitational force? Fg, G constant, M Earth times M sun divided by R squared. You can calculate and choose the correct answer. Which of the following is not correct? Interpretation of the expression Ag or free fall gravity is equal to Gme over R squared. Gravitational field strength changes with an object distance from the Earth. Okay, which of the following is correct? The free fall acceleration changes with an object's distance from the Earth. Free fall acceleration is independent of the falling object mass. All of the above are correct interpretation. Yes, of course. Let me repeat, please. Gravitational field strength changes with an object distance. Yes, it is inversely. Free fall acceleration, G, changes with an object distance. Yes, of course. G also inversely proportional. Okay? So free fall acceleration is independent of the falling object's mass. Yes, of course, because all the masses, they are reaching at the Earth with the same speed at the same time when the air resistance is neglected. Or in the absence of the air resistance, all the objects they are reaching at the ground at the same time. So it means that when we say gravity is equal to 9.81, this gravity is the gravity for all objects independent on the mass. So that is why D is correct. Okay, for example, if you release at some height a feather and a bowling ball, which one has more mass? Absolutely the bowling ball. So if you release at the same height at the same time, in the absence of air resistance in the vacuum chamber, which one landed at first, or which one moving faster? The same. Why? Because the gravity is pulling down with the 9.81 for all objects. Okay? Which of the following choices correctly describes the orbital relation between the Earth and the Sun? The Sun orbits the Earth in a perfect circle? No. Earth is orbiting the Sun in a perfect circle? No. The Sun orbits Earth? No. Earth orbits the Sun in ellipse with the Sun at one focus? Yes. The answer, correct answer is D. Which of the following statement is correct? Mass and weight both vary with location? No. Mass varies with location but weight no? No. Weight varies with location but mass not? Yes. C is correct. Neither mass nor weight varies with no. Okay. So the correct answer is what? A. C. Okay. Which astronomer discovered that planets travel in an elliptical rather than the circular path? Johannes Kepler. A. Johannes Kepler was the first scientist who discovered that planets travel in elliptical rather than the circular orbits. Okay. Are the bodies that move in a circular path in equilibrium? No, because when we talk about the equilibrium, net force must be zero for equilibrium. For what? For translational equilibrium. But in a circular motion, net force can never equal to zero. Why? Because for the circular motion, net force is equal to what? Is equal to Fc. Even the object is moving at constant speed. The net force is equal to what? Is equal to Fc. It means that when object is moving in a circular path at constant speed, can we say this object has equilibrium? No. The object can never become equilibrium in a circular motion. Why? Because net force in a circular motion can never be zero. Net force is equal to what? Fc for the centripetal, for the circular motion. But when an object is moving in a straight path, in a linear path, at constant velocity, can we say the object has equilibrium, or can we say the object at equilibrium? Yes, of course, because net force is zero for an object when it's moving at constant velocity. Okay? So this is the questions of the assessment guides, and the answer key is already here. You can check your answers. Hope you get benefited my lesson, and thank you for listening. See you inshallah in the next lesson in chapter 2. Thank you for listening.